Okay, good morning. So let us continue the discussion of vectors that we started yesterday. I will give you a little bit of time to think about this problem, to review a little bit, and then we continue. Just I will give you 2 or 3 minutes. These are very, very simple ones. You're supposed to simplify each item. Each item is a vector expression. If needed, draw a picture for yourself to convince yourself. Otherwise, you can use the Schall rule to answer this question. Okay, so this problem is easy, yes? So if you want to solve that, you really don't need to draw any pictures for yourself, because you can use the Schall's rule here, or if you want, you can use the Schall's rule here. Can I use the Schall's rule between this one and that one? In this way, no, but I can reorder them and then I can use the Schall's rule again. Yes, that's something that I wanted to know, because we learned that there is no difference between adding these two or adding these two in this order. Yes. This is also something that you need to be observant about, yes? So if I ask you, can I use the Schall rule in this form and in this order, the answer is no, but I hope that you agree with me, there is no difference between this sum and that sum. But in this sum, can I use the Schall's rule? So yes, so the answer to this is actually CB, yes? Because whenever I want to add two vectors, and then this middle point is the same, it seems that you can eliminate this and write CB. So this is also possible. But you really don't need to do that thing here, because now you can see the vectors next to each other here are actually forming the Schall rule. Or if you want, you can use these two first. It doesn't matter. By the way, why it doesn't matter is also important. This is because addition of vectors is associative. So do you remember, if I give you 3 numbers and I ask you to add them, I don't need to put a pair of brackets, because in principle I should prioritize which operation should be done first. But because addition of numbers is associative and the answer, the final answer, does not depend how I prioritize these operations, I don't need to prepare a bracket. But do you think also, we didn't discuss about that, we discussed a little bit about that we can interchange these two. This is not associativity, this is commutativity. It means that I can commute these two. Yes, so the order in addition is not important. But how should we convince ourselves, at least a little bit, why it is also associative? If I give you 3 vectors, U, V, and W, do you think there would be a difference? And if I am interested in adding these 3 vectors, do you think it matters if I calculate this, if I determine this sum first and add the result to W, or add V and W first and add U to it, yes? If this is indeed the case, we want to, I don't want to be very strict in this lesson, but intuitively, at least I want to draw some picture to motivate you. Yes, this is indeed the case. There is no difference. If I have 3 vectors and I want to add them, it doesn't matter in which way I group them. It doesn't matter if I change the order. It also doesn't matter in which way I group them. At least we can feel this a little bit. Okay, so for example, assume that I give you 3 vectors. This is vector U, and this is, for example, vector V, and this is, for example, vector W. For example, let us try to draw a figure so that we are somehow convinced that this equality is valid between these 3 vectors. So what I'm supposed to do, I want to calculate, I want to draw this picture. So the priority is with this operation. So it means that I have to add U and V first. So what should I do? Do you remember? If I want to add U and V,
parallel transport.
Yes, I have to parallel transport V from here. And then I have to have the same size, for example, in the same direction. Hopefully, yeah, more or less, this is the thing here. And this is, if the name of this vector is V, I can call this vector V as well, because they are exactly equal. Yes? And then what I'm supposed to do, I have to add them. It becomes a new vector. So this is the new vector U plus V. And then remember, you have to put the tip of the arrow at the end. So this is the vector U plus V. And then what I am supposed to do, so if you don't mind, let me draw this vector V in a different direction. Otherwise, I have to cross them, and it's so problematic a little bit. So let me consider W in this direction, just for clarity. Okay, so now that I have this green arrow, which represents this vector, I want to add this new vector to my W. So what I'm supposed to do, I can totally forget about everything, just consider this green vector and this W. So what I'm supposed to do, I have to parallel transport W from the tip of this green vector. So parallel transport means that I draw a line parallel to W, for example, and I will keep the length the same, a little bit more. So I would say that this roughly, this is a good picture. Okay? And then you draw this vector, final vector here. And then I want to add this green vector to this red vector. So this becomes this vector, yes. So if I ask you to write a name for it, this is vector U plus V first, and then add it to W. This orange vector is the result that I get if I add U and V together first, and then add the result to W. Yes? Now let us do the other side. But the good point is that now everything is parallel transported already, so I can use that. So I don't know which color I can use to make it clear. So I don't know. Let me draw everything with the blue. So if I ask you draw the picture here, what is the priority here? The priority is with V and W first. So I have to add V and W first. Yes? So if I want to add them, this becomes this vector. So if I ask you to write a name for this blue vector, you would say that this blue vector is V plus W. Yes? And what I am supposed to do, now I am supposed to add this new vector to this vector U. Are they in the right combination? You see, yes, they are in the right combination. If I want to add U, which is this black one, to V plus W, which is this blue one, I have to draw this one from the tip of that one, which is already done. So it is in the right combination. So I add them. So what will I get? I will get the same thing. Yes, do you agree? This is exactly the same thing, but make it clear, I just want to draw a dotted line here. And if I ask you what is this dotted vector, this is the other side. It is U plus V plus W. But I think that you agree with me that these two are actually coincide, yes? So it means that there is no difference between this vector and that vector. At least this is better than nothing, yes? You are more or less convinced that it doesn't matter how should I group them. So it doesn't matter in which order I am adding vectors, and it doesn't matter in which way I group them if I have more than two vectors to add. Yes, is that clear?
Yeah.
Okay, but that's also a good exercise for drawing vectors. So here at the bottom line is I have the addition of three vectors. I realize that it doesn't matter how I group them, so I will group these two together and write the answer and then add the answer to the next one. But you don't need any picture to calculate this, to determine this. What is that? It is AC by the Scholl rule. Yeah? So it becomes AC plus CA. For this one, you can have two arguments. Do you remember what was the relation between a vector AC and a vector that I interchanged the endpoints? Yes?
They're opposites.
They are opposite. So in principle, AC and CA are opposite, and I am adding them. So the answer would be the zero vector simply. Or can I use the Schall rule again? Yes, because this is a good combination, the right combination. So C is cancelled. I am getting A and A. But a vector which starts at A and ends at A is nothing except the zero vector. So the answer to this is the zero vector. Is that clear?
Yes, sir.
Now we go for the next one. How do you think about the next one? Yes?
Well, I personally, at least, I grouped the opposites with each other. So
Exactly.
AB.
So you take AB and put BA next to it. If someone asks you, is it allowed to do this? You would say yes, because it is commutative and associative, yes? So then I will take AC and CA, and we also take BC and CB. And then of course this is the zero vector, this is also the zero vector, that is also the zero vector, and then this becomes the zero vector.
Nice.
Okay, finally for the last one, what is your suggestion?
Yes. Well, I took first BA and BE and EA.
Yes, so you group them,
Yes.
so it becomes BE plus EA,
Yes, it's BA.
and then you have AD. So if you want to write equality, you have to be patient and write everything again.
Yeah.
Okay, and then?
And then BA plus AD. Yeah. BA
Okay, so
plus
this
A,
becomes
yeah.
BA,
That becomes BA.
and then you have plus
Yes.
AD plus CB,
Yeah.
and then
And BA plus AD becomes BD.
BD plus CB,
Yes.
yes?
And again, because of the
Yes, I can commute them,
yes.
so it becomes CB plus BD. Now it becomes the Schall rule, yes? So it becomes CD. So you see, the Schall rule is very good. If you don't have this Schall rule, you have to draw pictures. So doing algebra is a little bit easier than drawing pictures. But sometimes it is inevitable. Do you remember we had an example for the rectangular cube? Sometimes we have to have the picture in front of us. But sometimes we can just do the algebra. Yes? So I want you to learn both of them. So far we have introduced the notion of a vector, and we have defined how to add them and how to subtract them. Yes? Let us just delve a little bit more into it. Yes? So here, the way that we define addition of vectors sometimes is called a triangle method. And the reason is clear, because if I have two non-parallel vectors, let us say vector u, and I have another vector, vector v, if I ask you to add them, you parallel transport this here, yes, and then you say this is also v, and then this would be your vector. And of course, if I ask you what is this shape, you would say it's a triangle. So this is why it is usually called the triangle method. Yes, that's the original definition of adding two vectors. But there is also an alternative, especially it is important in physics in the future when you want to study physics, that is called parallelogram method to add two vectors. I want you to know both of them. So do you know the parallelogram? What is that? If I have a quadrilateral, a shape with four sides so that opposite sides are pairwise parallel. So this is called a parallelogram, yes? AB is parallel to DC, and AD is also parallel to BC. A shape with these properties is called a parallelogram. Yes? Of course, there are other properties that you can immediately guess, but in principle, you should be able to prove it later. So, for example, this side, from size point of view, is equal to this side. And this side will also be equal to this side. Yes? What about the diagonals? Do you think the diagonals should be the same? From size point of view? No. In general, no. If I draw this diagonal and if I draw this diagonal, one diagonal is longer, yes? But there is also a good property. They intersect at a point. This point is both the midpoint for this diagonal and the other diagonal. Of course, all of these things that I am mentioning, in principle, you should be able to prove them using Euclidean geometry. But this is not part of your lesson, so let us skip that. But in principle, I want you to know that this one and this one have the same size, and this one and that one have the same size. So if I call this intersection point O, then, so let me write the information. It's important for vectors to know this. AB is always equal to DC. AD is also equal to BC. OA is equal to OC. And OB is equal to OD. But there is no guarantee that OA is equal to OD or something like that. So these are the information I want you to know about this quadrilateral, which is called a parallelogram. Okay, another way to add two vectors, which will be important, especially in physics, not in mathematics that much, is called a parallelogram method. So what does it mean? Assume that I have the same two vectors, and I want to add them using parallelogram method. Okay, in the normal, so let me change my color here now. In the normal way, I have to parallel transport the second vector and draw it from the end of the first vector if I want to use the normal way of adding vectors, which is the triangle method. But if you somehow want to add them using this method that I want to describe, you again parallel transport it, but do not draw it from the end of this vector. You draw it from the initial point of this vector. Okay, so what you do, you just parallel transport it and put it here. Okay, so forget about these things. So you have only this vector and that vector. This is also vector v, there is no difference between them. And then, so you have this situation. You have vector u here, you have vector v here, and what you do, you complete the parallelogram. How? By drawing a line from here parallel to this side, and drawing a line from here parallel to this side. This is the meaning of completing the parallelogram. So I have two sides. I go from the tip of this one, draw a parallel line to this, and draw another parallel line to this. They intersect at a point. The initial point of two vectors connected to this intersection point is u plus v again. Yes? So in this picture you see that if I complete this parallelogram, the parallelogram after being completed is exactly this picture, and then I will take this one and connect it to this point, which gives me exactly the same vector. So if I give you two vectors, if they are drawn in this way, which method is suitable to add them? If they are drawn in this way already, I would prefer to draw using the triangle method. If they are already drawn in this way, it is better to use the parallelogram method. So how? By drawing a line parallel to this one and drawing a line parallel to this one. And then it is important to remember, take this point, the intersection point between the vectors, the initial point of both of them, and connect it to the opposite one. So this diagonal would be the sum of these vectors. I would never do usually the parallelogram method unless there is a good reason to do that. The weakness about the parallelogram method is that if you want to add three vectors together, then it is not that easy. I mean, So if I have three vectors, if I want to add three vectors using the normal triangle method, or the normal definition of the addition of vectors, it is easy. So for example, you see, if I give you three vectors, this vector, and that vector. If I want to add three vectors using this normal method, I parallel transport it from here. This becomes V, and then I parallel transport the third one from the last point of the second one. Yes? And then, even if I have more vectors, I will continue this method, and when it is finished, I will take the first initial point and connect it to the very last final point, and put the tip of the arrow there. So this becomes U plus V plus W. So you see, it's very straightforward. But if I want to do the same thing with the parallelogram method, this is also possible, but I have to do it case by case. What does it mean? So let me clean this picture. Okay, so remember that. I will clean this one now. So assume that you want to do it using parallelogram method all the time. So I have to parallel transport this one, but put it here. Yes? Then I have to add these two, find the answer, and do it with that one. So this is the reason that I cannot do it consecutively as before. So I have to complete the parallelogram. Yes? And this vector that I find is just U plus V. And then when this black one is found, I want to add this black one with this blue one, again using parallelogram method. So it means that I parallel transport this from here, because I want to use the parallelogram method. You see, I am trying to draw this line parallel to this one with the same size here. This becomes W, and then this black one and this red one should be added together using the parallelogram method again. So what should I do? I need to complete the parallelogram on these two. I take this point, draw a line parallel to this one, and then draw another line parallel to that one. And then when I find the intersection, I will connect these two. Yes? So then this becomes U plus V plus W. So you see, if you remember, it is more or less the same thing. If you draw this precisely, it becomes exactly the same vector. But this is more troublesome. So if you want to add consecutive vectors together, I would recommend you to add them using the normal triangle method. Yes? Is that understandable? Okay. But now, let us go back to the subtraction of vectors. So do you remember what was the subtraction of vectors? We talked about that yesterday. So if I want to subtract two vectors, do you remember? Let me give you an example. If I give you a vector u and a vector v, so let me draw them here. A vector u here, and I have a vector v here, for example. And I ask you to draw the vector u minus v. Or I can ask you to draw the vector v minus u. Of course, you should expect that they are not the same thing, yes? It's exactly like numbers. So do you remember what we are supposed to do for u minus v from the yesterday lesson? Anyone else? Yes?
U plus minus v.
Yeah, please.
U plus minus v.
U, yes, that is the reason. That was the definition. This is u plus minus v. Yes. So, but it means that I need to find minus v. So what is minus v? Yes?
It's so v goes
In the other direction. So for example, instead of, it is the simplest way to draw minus v is just to put this arrow, the tip of the arrow here. That is minus v, yes?
And then you
So if I ask you what is minus v, this is v, so this becomes, if this is v, then this becomes minus v. So this is minus v, yes? Yes?
And then you parallel transport.
Yeah, parallel transport this green arrow from the last point of this one. So it means that it should be parallel. I don't know if you can see it because from it's hard to draw parallel things here. And then with the same size, yes? So for example, if I ask you what is this vector is called minus v. Forget about the name. This is the right combination. One arrow is coming after the other arrow. And you want to add them. So if you want to add them, what you do, you will take the initial point and connect it here. So this vector is u minus v. Yes? But now, if I ask you to draw v minus u, what we are supposed to do? Let me draw it exactly in the same picture. So what is v minus u? What is your prediction? If I draw v minus u, how that vector will be related to this orange vector at the end? So assume that I have already drawn this vector. My question is that this becomes an arrow at the end. My question is that how that arrow is related to this orange arrow. What is your guess? Yes?
It's just going to be a flip.
That would be exact, because you know that exactly like numbers, yes? So if I ask you what is the relation between 2 minus 3 and 3 minus 2, one of them is the negative of the other one. That's the same story here. U minus v and v minus u are opposite to each other. So what we will get is the same vector but flipped. Yes, that is the intuition behind it. You have questions, Sergey?
Yes, if we use the parallelogram method to subtract them,
Yes?
if we draw the parallelogram using as if we were with addition, but instead of drawing the horizontal line, we'll draw the vertical, would it be the same?
Yes, I will come to that. Yes. Okay, but let me just do this one now. So I want to draw v minus u. So what do you think for v minus u? Let me draw v minus u in this picture. If I insist to draw v minus u in this picture, is it a good idea? Yes. So what is, if I want to draw minus u, do you agree that this is a good way to draw minus u? The same thing here. Do you agree with me? I can call this also minus u. That is one way of drawing minus u. Yes? And now I have this blue vector. I want to add u to this, where is it? Oh, here. I want to write this as v plus minus u. Okay, this is minus u. I want to add v to it. So what I do, I parallel transport v. I parallel transport v, but I draw it from the tip of this arrow. So it means that I will take this one and put it here, yes? So, somehow, I cannot draw them exactly. But then if I add this one and that one, this becomes this vector. So this vector is now vector what? V minus u. And then hopefully if you do it using GeoGebra, then you can immediately are convinced that these two vectors are of the same size. They lie on the same line, but they are pointing in different directions as you predicted before drawing it. Yes? Is that clear? But now, I want to go back. For me, drawing the subtraction is parallelogram is always easier. So let me tell you this. So if I give you two vectors, let me just draw them here. Let me draw this vector here. I will call it v. And let me draw this vector from the same place. So I will call it U. If I ask you to draw a U minus V in this kind of configuration, so what should I do? First of all, I need to find minus V. Do you agree? So what is minus V? This vector, I continue it from this side with the same size, yes, here. And this becomes minus V. Yes? And then, now forget about this blue vector here. Consider this blue vector and this red vector. I want to add them. Because of the configuration of these vectors, which one is more suitable here? If I want to use the triangle method, I have to parallel transport it here and then complete the triangle. But in this way, I will prefer to do it using parallelogram method. So I will complete the parallelogram. How? I take this point and draw a line parallel to this. Yes? And I will take this point and draw a line parallel to this one. Yes, they intersect at some point. I will take this initial point and connect it here. This orange vector here is the sum of this blue vector and the red vector. But the name of the red vector is minus V, so this vector is nothing except U minus V. Yes? Now let me ask you another question. If I just simply connect this point to that point, instead of doing all these things, and put the tip of the arrow here, I want you to see, it is not a very good picture, but hopefully you can realize that these two are equal. So they will be parallel, they will be of equal size, and they are pointing to the same direction. So if this vector is U minus V, this vector is also U minus V. How should I see this? It needs a little bit geometry to convince you. If you draw it using GeoGebra, you're 100% immediately convinced. But if you need more a rigorous way of proving, I have to prove that this picture is also a parallelogram. If I can show that this is a parallelogram, then I am done, because this becomes parallel to this, and the size will be the same. They are also pointing in the same direction, so they are the same. Okay, but we haven't studied those things, so I just want to skip them, and then you can just trust me or do it on GeoGebra. So what I'm saying is, if I want to find the difference of two vectors, it is better to draw them from the same point. Yes, if I give you these two vectors, U minus V, and if I ask you to find the subtraction U minus V, it matters, of course. What you need to do, you just connect the final points together. That's it. And then you need to know where to put the tip of the arrow. Yes? Where should I put it? It should point to the vector with the positive sign. So here U is the positive one, so you put this tip of the arrow here. So this would be U minus V. If I ask you to draw V minus U, then you have to put the tip of the arrow there. Yes? So that is up to you which one you want to use. But it is easier, you know, if the vectors are drawn from the same point and I ask you to find the subtraction of them, it's much easier to connect the final points and put the tip of the arrow pointing to the positive one. Yes? This is easier way to do. I want you to learn that one as well. And you don't need to memorize that, because you know that in this picture, if I ask you V plus this green vector, what is the answer? V plus this green vector, which is U minus V, becomes U. And in algebra, it's also correct, because V and minus V are cancelled, you get exactly U. Okay. But let me finalize this lesson with this part by this picture, which is very useful to memorize. Okay, so if I have two vectors, u and v, drawn from the same point. Yes? If I have two vectors drawn from the same point, if I complete the parallelogram, if I draw this diagonal, what is the name of this diagonal? Do you remember? What is that? Yes?
U plus V.
U plus V. The interesting thing is, the other diagonal, this is a good picture to remember for the people who also actually wants to join these competition problems. This is a good picture to remember. So if I have this parallelogram, so that this is one vector, this is another vector starting from the same point, one diagonal is u plus v. The diagonal which starts from the same initial point is u plus v. The other diagonal is u minus v. So this picture is very important to remember in your head, in your mind. So if I have this configuration, if I have two vectors, then one of the diagonals is u plus v, the other diagonal is u minus v. Okay, so that's extremely important to remember this picture. Yes?
So why?
You are talking so much, okay? Yes?
Why is this the case? Like how?
No, I just showed it here for you.
Yeah, I mean I know, but like,
Let us repeat it again. So this, I hope I could convince you that this is the u plus v.
yeah.
Yes? Now here in this picture, I convince you that if you have two vectors drawn from the same point, then if you want to find the subtraction of two vectors, you can just connect the final points and put the tip of the arrow pointing towards the positive one. So remember this whenever you have. If you are not convinced about that, I can repeat this one as well.
No, I get it.
So if you get it, then that's the same story. Try not to see the green one. You have this vector u, you have this vector v drawn from the same point, and I ask you to find this u minus v. Then what we are supposed to do, we have to connect the final points and put the tip of the arrow pointing towards the positive point. Yes? But if you draw it in the parallelogram, the picture would be nice. If I have two vectors as the adjacent sides of a parallelogram, one diagonal is u plus v as vectors, the other diagonal is u minus v as vectors. So that's a good picture to have in mind. Yes? Okay, so this, by the way, I haven't talked about the sizes. What do you remember? The symbol that I want to use for the norm, you remember there are three words, norm. Of course, the very simple word is the length. Okay, but sometimes people call it the norm. That's the same thing, or magnitude. Usually magnitude is used in physics, yes. So this symbol, I presented this symbol is not in your book. If you see this symbol, it means the length of the vector. The symbol in the book is probably this one. But they are the same thing. Okay, let me ask you one question. If I have two vectors and add them and then measure the length, yes? I give you two vectors, you add them first, and then you take your ruler and measure the length of the sum. What is it, so, and then let us do it separately. You take your ruler and measure the length of u first, and then again take your ruler and measure the length of v, and then add them together. So here you add the vectors first and then measure the length. Here you first measure the lengths and then add the numbers. Yes? Do you think they are equal or not? It's clear in general the answer is no. Yes, for example, if this is the vector u and this is the vector v, if I add them, it becomes this vector. Okay? I don't know how many of you have seen this theorem before. That's a very famous theorem in Euclidean geometry. So that it tells you that the length of each side of a triangle is less than the sum of the sizes of the other two sides. Yes? So each triangle. So I don't know what is in the Persian culture, donkey is the symbol of stupidity. And then this is, by the way, in Arabian, I think I read it somewhere, so it is called the donkey theorem, meaning that if you have the donkey standing here and the food of the donkey is there, the donkey knows to go directly and get the food. The donkey will not go through this path, will go the straight path. Yes, it knows, it says that, okay, if the donkey knows that this is the shortest path, let alone the humans, yes? So, but of course this is not a mathematical way of proving things. In Euclidean geometry you can prove that if I have a triangle, any triangle, and this length is A, this length is B, this length is C, it's a very famous inequality. Any of these numbers is smaller than the sum of the other two. Okay? If this is not the case, you are not looking at the triangle. The triangle has this property. The length of each side is smaller than the sum of the lengths of the other two sides. And this is not called the donkey theorem. It is called the triangle theorem. Triangle inequality, sorry. Okay? So, in principle, so if I want to, instead of this question mark, I erase that. What is the correct symbol that I have to put between this and that? Yes, which one?
Smaller.
A smaller, yes. This is a small. Okay, but this is not 100% correct. Can you correct me? It's 90. I don't know. It's 99% correct, but there is some exception, not for triangles but for vectors. So my question is that: is it possible to have equality? Ali.
If you write, if the vectors is the same direction and you add them together.
In the same direction, they add them together. That would be equality. Yes. So yes. This is not possible for a triangle. So if I have this scenario, assume that this is U and then this is V. So let me just draw it here. So this is V. And I want to determine U plus V first. So what is U plus V? I have to parallel transport it and put it here. This is also V. And then from the initial point to the final point, I have to draw, I just want to make it clear, so I just draw it very close to it. So this becomes U plus V. Now, do you agree with this picture, with me here, that if I measure the length of this new vector, it is exactly equal to the length of this one plus the length of that one, yes? So in principle, it is possible sometimes that they are equal. But this is not something, equality is not something that we can rely on unless we have some extra information. This is called triangle inequality for vectors. So be careful, don't get confused. The length of the sum is not the sum of the lengths in general. Yes? Of course, in triangle, if we have a triangle, we do not have equality signs. Yes, because this scenario, by the way, this is also called a triangle in mathematical terminology, but this is called a degenerate triangle. Yes, yeah, that is also the word that mathematicians use actually. So if you have a straight line like this with this vertex or here, if I call it A, if I call it B, if I call it C, here I can call this A, I can call this point B, I can call this point C. Of course, A, B, C is a degenerate triangle. Yes, you have actually killed the property of the triangle. Yes,
So, is it actually? It's not a triangle, right?
that's called a degenerate triangle.
Yeah, well, I
You
mean,
destroy the triangle.
there's no angles, so.
Yeah, you are right. So that's what I'm saying. That in principle, this is not. This is the terminology that sometimes we use. Degenerate triangle, but a degenerate triangle doesn't have the properties. If you are also degenerate, there is no reason that you have heart or brain. Yes. Yes, so let alone the angles. Yes. Okay.
So technically, that line is 180 degrees, which is...
Yeah, exactly. This one, it depends. If I start pressing this, what happens? This angle becomes itself 180. These two angles become 0. And still, you can talk about angles, yes? Okay. This is also something I want you to know. But there is also another thing about vectors. There is another operation that you will learn at this level, and that is how to multiply a number by a vector. Before I define it for you, I think you can think about, if you are a mathematician, how do you define it? For example, I give you a vector. Of course, these are definitions. I can just write the definitions. But I want you to have the motivation why this definition is a natural definition that mathematicians have chosen for this. For example, if I give you a vector A here, I want to somehow define what do I mean by 2A. Yes? Yes?
I feel like it's easier.
Yes, that's exactly. So when you say in numbers, when I say 2x, what do I mean by this symbol? I mean x plus x. So if I want to give a meaning to this symbol, 2 times a vector A, I prefer to keep the algebra as before. So it means that I want to define it in a way that the answer becomes A plus A. Because if I define it in a way that this becomes equal to this, I do not need to be worried about new algebra. The new algebra follows the old algebra. Yes? So that's a good motivation. So it means that, by the way, if I ask you to draw A plus A, you know how to do it. What you're supposed to do, you just parallel transport the vector from the tip of the own vector. This is also A, and then you take the initial point and connect it to this final point. Yes? And this becomes A plus A. Is it a good candidate for 2A? It seems so. So if I want to understand this, if I give you a vector and I ask you to multiply it by 2, what do you think it's a good idea? You just draw a vector parallel to this one, pointing to the same direction, but the length of the new vector should be 2 times larger than the original vector. Is that understandable? Okay. But, of course, this is an analogy to give me the motivation of the definition, but the definitions can go beyond that. So what I'm saying is that if I give you any vector and I ask you to multiply it by any number, any positive number for the time being, for example, can you tell me, if I ask you to determine 5A, what I'm supposed to do? Yes? Okay, but then at the end what will happen? It means that I draw a line parallel to this one. Yes? And I take 5 copies of that. 1 times, 2 times, 3 times, 4 times, 5 times. It's a very bad example. Yes? And then this vector from here to there is 5A. Yes, is that understandable? So, for positive numbers, we realize this is good. If I ask you to draw 0.5a, that is also possible now. Yes, what should I do this time? I draw a line parallel to this vector, and then I calculate the size, divide it by 2, or multiply it by 0.5, it becomes half of it, and then I put it here. Yes. So this vector would be 0.5a. Or of course, I don't use decimal points, I would write 1/2 times a. Yes? So that is good. So it doesn't matter what is the number, if this is bigger than 1 or smaller than 1, I know what to do. But what about negative numbers? So what do you think would be a good definition for minus 2a? Yes?
It's going the other way.
Yes, it is 2a, but in the opposite way. Yes? So if I have a negative number, I will draw again the same thing. I will draw a line parallel to this one. I separate 2 times of this here and there. But instead of taking it in the same direction, I take it in the opposite direction. So this becomes minus 2a. Yes? Is that clear? So the result, so this is the motivation, but I finally want to define it for you, yes? So if I give you a vector, so I would say that let U be a vector and C a number. Any number that you like. When I say any number, it might be 0, it might be larger than 0, it might be smaller than 0. And then what is the meaning of C multiplied by U? Cu is a vector. I emphasize on this word. So if I give you a number and I give you a vector and I ask you to, first of all, if I ask you to add them, it is meaningless. Yes, I cannot ask you to add a number to a vector because they are different quantities. Yes? I cannot ask you to determine U minus C. One vector minus a number. It's meaningless. But I can ask you to multiply your vector by a number. Okay? The answer is not a number. The answer is again a vector. Okay? I would say that this vector is parallel to this vector, to the original vector. So Cu is parallel to U. The length of Cu is the length of U multiplied by that number, if the number is positive, and it is negative of that number if the number is negative. So you write it as absolute value of C. Yes? And then Cu points to the same direction as U if C is positive, and points to the opposite direction if what? If C is negative. So might be, I hope that you understand this symbol. Do you understand that? This tells you that the norm, the length of this vector is equal to the length of the original vector multiplied by your number. But of course, if your number is negative, this is meaningless, yes? If I ask you what is the norm of this vector, if you carelessly write minus 2 norm U, this is definitely wrong, yes? Because the norm of a vector is positive, but this one is negative. And a positive number cannot be equal to a negative number. So this is why we have to write the magnitude of the number, yes? Okay. And then one question is still left. I am talking about C positive, I am talking about C negative. One case is not considered yet. What is that case? Yes?
If it's equal to 0.
If it is equal to 0. What do you think it is a good definition? If I multiply 0 by u, if you are a mathematician, how do you define it? Yes, Oscar?
It's the 0 vector.
The 0 vector. It's extremely important to not write 0 in front. That would be wrong. Because I told you that multiplying a number by a vector is supposed to produce you a vector by definition. So if you ask me what is 0 times vector u, if you just write 0, this is wrong. You have to write the vector 0. That is also part of the definition. Okay, now can you tell me, if I take 5 and multiply it by the 0 vector, what is the expectation that you have here?
The 0 vector.
Again, the 0 vector. So you see, it doesn't matter. If I multiply the number 0 by any vector, the answer would be the 0 vector. Or if I take any number and multiply it by the 0 vector, the answer is again the 0 vector. Of course, if I multiply 0 by the 0 vector, the answer is again the 0 vector. Yes? Is that clear?
Yes.
Okay. So now, for example, so let me write a very important remark. This is extremely important. So it's very simple but important. So remark. Two non-zero vectors are parallel if and only if IFF is not a misprint in mathematical text. It means if and only if. If and only if one of them, any of them, is a multiple of the other one. Okay, let me ask you one question. I give you this vector A, okay, and I tell you the norm of this vector is 5. Now I draw another vector parallel to A, so this vector B, I tell you that B is parallel to A, and I tell you that the norm of B is 10. 10, 5 length unit, 10 length unit, whatever it is. So can you tell me what is the relation between B and A? Yes?
B equals 2A.
2A. Is that right? Because if two vectors are parallel, one of them is a multiple of the other one. So definitely B is a multiple of A. But which multiple? It is clear. The length of this one is 10. The length of that one is 5. What that multiple should be? 2. Yes? If I give you the same thing, but I put the arrow here, if this is B, then what should I write instead of C? Minus 2. So you see, it's extremely important. It's minus 2. Okay, let me ask you another question. I will take this one and make it 5, and let me take this B, the same thing, and make it 7. So then, I still have B parallel to A. The length of A is 5. The length of B is 7. What is the relation between B and A? Still, because B is parallel to A, B is still multiple of A. Positive multiple of negative multiple, because they are pointing to the same direction, positive multiple. But what that multiple is in this case? Yes, Ali?
1.4.
Can you give it in fraction form? That's correct. 7 over 4. 7 over 4. So this one, 7 over 5, sorry. 7 over 5. Yes? So this is 7 over 5. Why? Because the length of this one is 5. If I multiply the length of this one by this number, 7 over 5, it generates 7, and 7 is exactly the length of the other one. So it is easy to understand how we can calculate that. Can you find a general formula for me? I give you A here, and I just draw another vector here. Okay? B is equal to a multiple of A. Everyone agrees, yes? Because they are parallel. But I haven't given you numbers. How can I find this number? Yes?
Yeah, it's B over A, right?
Not B over A. By the way, B over A is meaningless. I don't know how to divide two vectors. You are very close, but
The absolute value.
norm, that is called norm.
The norm.
Yes, exactly. So this B, this C is nothing except norm of B divided by norm of A. Is this meaningful? Yes, because this is a number, I am dividing two numbers, which is meaningful. But if you write B over A, even if you mean this, that is wrong. Because I don't know how to divide two arrows, yes? I only know how to divide two numbers. Yes? So now you see that you can understand this concept. So if two vectors, now tell me, I will take this one and put the arrow here. So what will happen? This time B is equal to A. What should I write here?
Negative.
Negative of, again, norm of B over norm of A. Yes? Is that clear? Yes or no?
Yes.
Okay. So this is extremely important remark. Remember that. Another thing that I want to talk about is another example. I don't know, sometimes I have seen in the books they write this. I really want to avoid this. Even though when they write this, they mean 1/3 multiplied by A. I always, because in vectors we don't define division. We only define multiplication. And of course some people use this notation for this, but I will not use this, okay? I don't know if in the book they have used this or not, I don't know. But I always, if I want to divide a vector by a number, instead of writing in this with this division symbol, I would write this number multiplied by my vector. And we never have this one. You will never see this one. Yes? Okay, now let me give you a vector here. For example, this vector. And I give you this vector here. And I ask you to draw this vector. I want to draw this vector. That is also possible now, yes? Because a vector is an arrow. I know how to draw 2A. I know how to draw 1 over 2B. These are two new arrows, then I add them. Yes? How? What is 2A? I don't know. If you don't mind, let me start from here. For 2A, I draw a line parallel to A. Because 2 is positive, I will take this one 1 times, 2 times, I don't know. This becomes, for example, you can use GeoGebra to do it very precisely. Then this becomes 2A. And then 1/2 B, because I want to add these two vectors, I will parallel transport it from the final point here, but of course I have 1/2. So what I have to do, I need to draw a line parallel to this one, hopefully this is parallel. And because 1/2 is positive, the direction should be the same, but the length should be 1/2, yes? So if this is 1/2, so this becomes something like that. So this would be 1 over 2b, and then I add this vector to that vector. So this vector is 2a plus 1/2 b. That is the vector that I want to draw. Is that understandable? Of course, if you want to be very strict, we have to prove everything related to these things, but everything is normal. So the good news is that the algebra is trivial. What I mean, it means that if you want to multiply 2 by 3, if you want to multiply 2 by 3a, the answer that you guess is 6a is actually the correct answer. But of course, I need to prove that this property holds. Okay, because we don't know that this algebra is still the same algebra as before, but the good news is that, trust me, the algebra is as before. So for example, if I have 2 and I want to add it to the sum of 2 vectors, I can do the same algebra that I do with numbers. It is not trivial at all. I want you to understand that you need to convince yourself that this is the case, but this becomes the case. So this becomes 2a plus 2b. Yes? So this is, you can distribute this. If you have two numbers, 2 plus 3 times a, you can write 2a plus 3a. So the algebra is not confusing at all. So whatever algebra you had for numbers, you had for numbers multiplied by vectors. Yes? So these algebras are valid. So by the way, what do you expect? What happens if I multiply 1 by my vector? You shouldn't put this. What is 1 times vector? It's the vector itself. But don't think that this is trivial. Because 1 times x is x, you cannot say that 1 times by any number is the number itself, so 1 times the vector is equal to vector itself. No, this rule is for numbers. I want you to understand, you have to motivate this. Why this is correct? Because 1 times a is a vector parallel to a, pointing to the same direction as a, because 1 is positive, having the length 1 times larger than a, which is the same length. So this becomes a itself. This is the reason. What do you guess will happen if I multiply a vector by a negative 1? Yes?
Minus a vector.
It becomes a minus a vector. But not because minus 1 times a number is minus x. Not because of that. Yes? Exactly. Okay. So I think I will stop here. The vectors are not finished yet. I want to at least spend 2 sessions for completing the vectors. But I think this session is very long. You will be tired a little bit. So I will stop here, and then you can start working. You have nearly 35 minutes, 5 minutes resting, and then come back and work for 30 minutes. Okay? And then if you have questions, please let me know. Thank you.